Welcome to Talk Tensors, the show that takes a deep dive into machine learning research.
And today we're diving into DeblurDiNAT,
DeblurDiNAT.
a compact model with exceptional generalization and visual fidelity on unseen domains.
Interesting title.
Yeah, we can tell from the title that this paper is all about getting rid of blurs in images.
Deblurring, yeah.
But it's not just about making those images, technically sharper. It's about creating images that look good to the human eye,
Right.
which is where that visual fidelity comes in.
Visual fidelity, yeah, that's important.
And then there's this whole thing about generalization.
Yeah, I was going to say the generalization part of the title definitely caught my eye.
It suggests that this model can handle a pretty wide range of blurry images.
Not just the ones that it was specifically trained on.
Right, exactly.
Which is a big deal in
yeah,
deep learning.
is a really big deal.
Yeah.
A lot of previous deblurring methods really struggle when they're used on real-world images, which are often very different from those carefully curated data sets that they were trained on.
So they can do well on those benchmarks, but then
that fall apart in the wild.
they fall apart out in the real world.
Yeah.
Like students who ace the practice test but then freeze up on exam day.
Exactly like that.
Yeah.
And this paper actually highlights that issue.
Oh, does it?
It even points out how some state-of-the-art models
Yeah.
exhibit something called mode collapse.
Mode collapse.
Yeah, essentially instead of deblurring the image, they just add noise to it.
Oh, so the opposite of what you want.
Yeah, not exactly what you want in a deblurring tool.
No, not at all.
Yeah,
That's got to be frustrating for the researchers who developed those models.
I'm sure it is.
So how does this DeblurDiNAT avoid that pitfall?
Right, so the paper mentioned some really cool innovations.
Yeah, let's hear about them.
One key innovation is the alternating dilation factor structure.
Alternating dilation factor structure.
Yeah, that's a mouthful.
It is.
But basically, it's a way for the model to analyze blur at different scales.
Different scales.
So imagine looking at a blurry image through both a magnifying glass and a wide-angle lens.
Okay.
That's essentially what this structure allows the model to do.
I like that analogy.
So it's not just looking at the overall blur,
Right.
it's also considering tiny localized blurs within the image.
Oh, interesting. So it's looking at like the fine details and the big picture,
Precisely.
Yeah.
And by doing that, it can handle a much wider variety of blurs.
which leads to better generalization.
Exactly.
Okay, that makes sense. But what about color?
Right.
Blurry images often have weird color issues too.
They do.
How does DeblurDiNAT address that?
That's where channel-aware self-attention comes in, or CISA for short.
They say.
This component focuses on the relationships between color channels in the image.
So it's not just sharpening the image, it's making sure the colors are right too.
Exactly. It's like having a color expert fine-tuning the image after it's been deblurred.
Okay.
This helps to create images that are not only sharp, but also have natural-looking colors.
So DeblurDiNAT seems to be focusing on making images look good to human eyes,
Yeah.
not just optimizing for like technical metrics.
You got it.
It's like they're trying to bridge that gap between the technical and the human.
That's a great way to put it. And this human-centric approach is a key theme in this paper. And it's reflected in how they evaluated the model, too.
How so?
They used traditional metrics like PSNR,
Uh-huh.
but they also prioritized perceptual metrics.
Which are more in line with how humans perceive image quality.
Precisely.
Fascinating. So they're training the model to understand what we find visually appealing, not just what a mathematical formula says is a good image.
Exactly.
That's a really interesting approach.
Yeah, and this is a trend we're seeing more and more in AI research, this shift towards building models that align with human perception.
Okay, well, before we dive into the specifics of how DeblurDiNAT works,
Sure.
let's take a quick step back and look at the history of image deblurring.
Okay.
How do we get to this point where AI is playing such a big role?
Well, image deblurring actually has roots in signal processing and mathematics.
Really?
Yeah, before deep learning researchers relied on complex mathematical models
I see.
to try and reverse engineer that blurring process.
So they had to kind of guess how the image got blurry in the first place.
Yeah, basically.
That sounds pretty tricky.
It was tricky, and it really limited their effectiveness.
Especially with real-world images where the blurring could be quite complex.
Exactly.
So when did deep learning come into the picture?
The rise of convolutional neural networks, or CNNs,
CNNs.
really revolutionized image deblurring.
Yeah.
These powerful deep learning models could learn to identify and remove blur from massive data sets of images.
And that led to a significant improvement in deblurring quality, I imagine.
Absolutely. Models like MIMO-UNet and NPRNet really pushed the boundaries.
But they still face limitations.
They did, especially when it came to generalization.
Right.
They often struggled with real-world images that were different from the data they were trained on.
Which brings us back to DeblurDiNAT,
It does.
which seems to be building on these foundations but taking a different approach.
Precisely by focusing on generalization and visual fidelity, DeblurDiNAT is addressing some of those key challenges that have plagued previous methods.
This is all super interesting.
Yeah.
Now I'm ready to get into the nitty-gritty of how this model actually works.
Let's do it. Welcome back to Talk Tensors.
I'm ready to dive into the architecture of DeblurDiNAT.
All right, let's get under the hood and explore how this model works.
Yeah, what's the secret sauce that makes this model tick?
Okay, so at its core, DeblurDiNAT is a hybrid encoder-decoder transformer.
A transformer.
Yeah, think of it as a two-part system.
Okay.
The encoder part analyzes that blurry image
Uh-huh.
and extracts important features.
Okay, so it's like a detective gathering clues at a crime scene.
I like that analogy, yeah.
Yeah.
The encoder breaks that blurry image down into manageable chunks,
Okay.
and it identifies the patterns that represent the blur.
Okay, so then what does the decoder do with those clues?
So the decoder takes those features, the ones extracted by the encoder,
Right.
and uses them to reconstruct a clean, deblurred image.
Okay, so it's like an artist piecing together a masterpiece from those clues.
Exactly.
I like it.
So it's a real team effort.
Okay, so where do those alternating local and global transformer blocks come in?
Ah, yes.
We talked about the zoom levels earlier.
Right. Those blocks are really the key to DeblurDiNAT's ability to handle blur at those different scales.
Okay.
So the local blocks focus on small, localized blurs.
Okay.
Think of them as fine-tuning the details.
So like sharpening the edges of individual objects in the image.
Exactly. And then you've got the global blocks.
Uh-huh.
They capture the large, widespread blurs that affect the whole image.
So they provide the big picture context.
Exactly.
Okay, so by considering both the small details and the overall blur,
Right.
the model can create a more accurate and realistic deblurred image.
Precisely.
That makes sense.
And then we have that clever channel-aware self-attention mechanism. Queso, yeah, remember we talked about how it helps with color accuracy?
Yeah, it's like a color expert fine-tuning the image.
Right.
But how does it actually work?
So Queso allows the model to actually analyze how those different colors interact with each other.
Interesting.
Think of it as understanding the relationships between neighboring pixels.
So it's not just about making each color accurate in isolation.
Yeah,
It's about making sure that those colors blend together naturally and realistically.
exactly. And this is particularly important for real-world images,
Yeah,
which often have complex lighting and subtle color variations.
right. Real-world lighting is tough.
It is.
Yeah.
And Queso helps DeblurDiNAT avoid those artificial-looking color artifacts that you sometimes see with other deblurring methods.
Yeah, nobody wants those.
No, definitely not.
I'm really starting to appreciate the thought and ingenuity that went into designing this model.
Yeah, me too.
But the paper also mentions a couple of other components.
Yes.
DMFN and LDFF.
Yeah.
What are those all about?
So those are all about efficiency and effectiveness.
Okay.
DMFN stands for Divide and Multiply Feed Forward Network.
Okay.
And it's a more streamlined way of processing information within those transformer blocks.
So it's like optimizing the model's workflow to make it faster.
Exactly, making that model run more efficiently without sacrificing performance.
Okay, I liked it.
And then we have LDFF,
LDFM.
which stands for Lightweight Dual Stage Feature Fusion.
Catchy.
And this component combines information from different parts of the model.
So it's like taking the best insights from each zoom level and merging them together.
Precisely. It's about integrating the information from those local and global blocks to create a more comprehensive and accurate deblurred image.
Wow, it's amazing how all these different components work together.
Yeah, it's like a symphony of algorithms.
The symphony of algorithms. I love that.
Yeah, each part playing its role.
It really is a testament to the researchers' deep understanding of these architectures.
Absolutely.
They've carefully crafted each component to optimize both the performance and efficiency.
It's really impressive.
Okay, so I think I've got a pretty good grasp on how DeblurDiNAT works now,
Great.
but how does this translate to, like, real-world applications?
Right.
What are the broader implications of this research?
Yeah, that's a great question and a great segue, I think.
Yeah.
Let's shift gears in this final part of our deep dive
Okay.
and explore the bigger picture of DeblurDiNAT's impact.
Sounds good. I'm excited.
Stay tuned, folks. There's much more to uncover.
Welcome back to Talk Tensors.
We've been exploring the inner workings of DeblurDiNAT.
Yeah, really getting into the nuts and bolts.
But now let's zoom out a little
Okay.
and consider that bigger picture.
Yeah, the bigger picture.
Because this research isn't just about making blurry photos clearer.
Right.
It's pointing to a broader shift happening in AI.
I'm intrigued. What kind of shift are we talking about?
Well, we're moving beyond just chasing benchmarks,
Okay.
and focusing on those metrics that really align with human perception.
So bridging the gap between the technical and the human?
Yeah, making AI that not only understands, but actually enhances our experiences.
Like it.
DeblurDiNAT's emphasis on visual fidelity.
Right.
That's a great example of this.
Okay.
It's not just about making images technically sharp.
Right.
It's about making them look good to us, to the human eye.
And that could have a huge impact on so many different fields.
So many.
Photography, art design?
Even medicine.
Yeah, medicine, for sure.
Imagine a world where your smartphone camera,
Uh-huh.
it automatically deblurs photos
Okay.
in a way that's both technically and aesthetically pleasing.
Yeah, that would be amazing.
Think about the potential for medical imaging.
Oh, yeah.
Sharper, clearer scans could lead to earlier and more accurate diagnoses.
Absolutely life-saving stuff.
Exactly.
And what about self-driving cars?
Oh, yeah, that's a big one.
If they can see the world more clearly, they'll be safer and more reliable.
Absolutely. DeblurDiNAT's research has the potential to ripple out, impact countless industries.
It's really exciting to think about.
It's a reminder that AI isn't just about those abstract algorithms.
Right.
It's about solving real-world problems
Yeah.
and improving human lives.
Making a difference.
Exactly.
Okay, so lots of potential benefits.
Definitely.
But are there any downsides or challenges that we should consider?
That's a great question. It's always important to think critically
Yeah.
about the implications of any new powerful technology,
Especially AI.
especially AI. One potential concern is misuse.
Misuse, okay.
We need to be really careful
Mhm.
to prevent these deblurring algorithms from being used
Yeah.
to create fake images or to manipulate reality in harmful ways.
So ensuring that this technology is used responsibly and ethically?
Exactly. We
Yeah.
need to have these open and honest conversations
Yeah.
about the potential impact of AI.
Both the good and the bad.
Both the good and the bad researchers, developers, policymakers,
Right.
even everyday users all have a role to play.
It's a balancing act for sure.
She is.
But one that we really need to get right.
Yeah.
So what's next for deblurring research?
Right. Where do we go from here?
Yeah, what's on the horizon?
That's where things get really interesting.
Okay.
DeblurDiNAT opens up some exciting avenues for future exploration.
Like what?
Remember how it uses that channel-aware self-attention?
Uh-huh. To analyze those color relationships?
Right. What if we could push that concept even further?
Yeah.
What if we could train a model
Yeah.
to not only understand those color relationships,
Mhm.
but also to incorporate human aesthetic preferences?
So instead of just making the colors technically accurate, it would actually make the image look more aesthetically pleasing.
Precisely, imagine a world where your phone automatically enhances your blurry photos
Okay.
to be both technically sharp and artistically stunning.
Wow, that's a future I'm excited about.
Me too. That's something worth striving for.
Well, that's all the time we have for this deep dive into DeblurDiNAT.
It really flew by.
Thanks for joining us on Talk Tensors.
It's been a pleasure exploring this groundbreaking research with you.
As always, we encourage you to delve deeper into the paper yourself.
Yeah, the link is in the show notes.
Until next time, keep those minds curious.